Hello everyone, welcome to Punnett Square Problems Part 2 dedicated to beginners. So what is the problem we have? Suppose there is incomplete dominance in flowers, RR referring to red, RW pink, WW white. Question number 1, what is the probability of producing red flower from red and pink flower? And question number 2, what is the probability of producing red flower from two pink flowers? Okay, to solve this problem we will create Punnett Square. Okay, first to question number 1. So we have to produce from red flower red and pink flower. So we will use red flower. So red flower's genotype is RR, and we will also use pink flower whose genotype is RW. Okay, so now let's create Punnett Square. Okay, so this is our Punnett Square, and here red, okay, for red flower R, and for pink flower RW. Okay, R times R, here it will be RR. R times R, here also it will be RR. W times R, here it will be RW. I didn't write it WR because pink is RW. And W times R, here it will be RW. So what is the question? Question is, what is the probability of producing red flower? So if you look at this Punnett Square, so only this genotype represents this one, and this one actually represents red flower, whereas these two, they represent pink flower. So what is the probability then? Out of the 4 cases, in 2 cases out of the 4, there is a probability that the red flower can be produced, so which is 1/2, which is 50%. Okay, so this is the probability. This is the solution of question number 1. Now moving to question number 2. Question number 2 is what is the probability of producing red flower from 2 pink flowers? So what is the genotype of pink flower? Pink, we have RW. Okay, let's again create Punnett Square. Sorry, maybe I'll just cut it. I'm just going to create Punnett Square here, and yep. Okay, so 2 pink flowers, so we will write the genotype R and W. This is pink flower 1, and R and W, this is pink flower 2. R times R, here it will be RR. R times W, here it will be RW. And so W times R, here it will be RW, and W times W, here it will be WW. So what is the question? The question is, what is the probability of producing red flower from 2 pink flowers? So if you look at these genotypes, this is the only case where red flower has been produced. This refers to pink, this refers to pink, and this is white. So which means only 1 time out of the 4 probable times the red flower is produced, hence the probability is 25%. Okay, 1/4. So now moving to question number 2. So question number 2 is a cat FFBB having black fur and blue eyes meets with another cat FFBB with white fur and brown eyes. What is the probability of producing baby cat with black fur and brown eyes? This is question number 1, and there are 4 other questions which we will solve one by one. Okay, first, so we have 2 cats, right? So cat 1 is capital F, small f, okay, and small b. This is cat 1, and cat 2 is small f, capital B, and small b. This is cat 2. And let's create Punnett Square. Okay, so 1, 2, oops, sorry, I think I'm gonna have to use eraser. Okay, erase this, yeah, and I'll just take back my pen. Okay, so let's, yeah, and okay, 1, 2, and this is 3, and let's say this is 4. Okay, so here we will not put these F, capital F here, and small f here, and small b here, and here also F, and we will not do like that. So how we will do, I will show it here. Okay, so the first cat is capital F, small f, okay, and small b, and small b. Okay, so then, so first what we will do is that this first f will pair with this, and this f will pair with this. So which means capital F, small b, and capital F, small b. Okay, and this small f will pair with this b, and this small f will pair with this b. So which means small f, small b, and here small f, this is small f, small b. Okay, so this is capital. Okay, yeah. So, and for another cat, this is cat 1, right? This is cat 1. So for cat 2, what we have? We have small f, capital B, and small b. So this is one box, and this is another box. Same pairing. So small f will pair with this, and this will pair with this. This will pair with this, and this will pair with this. So basically, small f, capital B, small f, okay, small f, small b, and small f, capital B, and small f, small b. Okay, so here what will happen? So here we will have capital F, small f, capital B, small b. Okay, we just need to fill this up. And capital F, small f, capital B, small b, and here small f, small capital B, and small b. Okay, here small f, and capital B, and small b. Okay, it's a little bit time consuming. You guys can pause this video and fill it up yourself. Okay, so here capital F, small b, small b, and capital F, small b, and here small f, small b, and here small f, small b, small b. Okay, here capital F, small f, okay, this is capital F and small f, capital B, small b, and here okay, next is capital F, small f, and then capital B, small b. Okay, here will be small f, capital B, and small b, and here it will be small f, okay, and capital B and small b, and here, so capital F, small f, small b and small b, and here it will be capital F, small b, and here it will be small f, small b, and finally here it will be small f, and small b. Okay, so now we fill this Punnett square, guys. Okay, it was a little bit time consuming. You guys also can forward this video. Okay, so now the question is, first question is, what is the probability of producing a baby cat with black fur and brown eyes? Okay, so for the question number 1, so we are looking for black fur. Okay, so black fur. Okay, black fur, that means a black fur. Okay, for black fur, so it will be capital F. We will look for at least one capital F, and brown eyes. Okay, so brown eyes, that means we will look for at least one capital B. Okay, so in this Punnett square, where we have at one capital F and one capital B, okay, I will change the color of the ink so that the demonstration is better. Okay, let me change it to this color. Okay, so if you look here, actually in this case we have one capital F and one capital B. This is one, but here we only have one capital F, of course, here also, and one capital B. Okay, here we don't, both are small, and here we don't, here also we don't, and here we don't, and here, yes, we have one capital F and one capital B, and here also we have one capital F and one capital B. Here we don't, two small f, and here we don't, and here we don't. So basically, out of the total 16 cases, in 4 cases we have this one capital F and one capital B, so which means that, which is 1/4, that is equals to 25%. Okay, so what is the probability of producing baby cat with black fur and brown eyes? That is 25%. Okay, so this is the solution to question number 1. And question number 2 is, what is the probability that baby cat will have white fur and blue eyes? Okay, to solve this, I will just erase this. Okay, let me just quickly erase this one. Eraser. Yeah, I'll just erase it so that I have more space. Okay, sorry for the delay. Yeah. Okay, let me just also get rid of things here. Yeah. For some reason my laptop is not responding so well. Okay. Yes, and just this one also, let's say. Yep. And I will also get rid of this number 1. Yeah. Okay. Okay, so let me go back to the pointer and get my pen back. Okay. So maybe I change the color also of the pen. So I'm just gonna take, let's say, color this time will be this one. Okay, sorry. So what is the probability that the baby cat will have white fur? Okay, so to have white fur, should have one small f, and blue eyes, to have blue eyes should be small b. Okay, so to solve question number 2, okay, question number 2, so white fur, okay, white fur. So to have white fur, what should we have? We should have small f, at least one small f, okay. And blue eyes, to have blue eyes, we should have at least one small b. Okay, so now I will look here. So when this has, I mean, not at least one small f, one, because it is the recessive character. So I mean, not only one, actually we should have 2 of which, yeah. So then here it is small f, no, yes, here I see that here we have small f and small b. This is one scenario, and here also we have the same thing. This is 2, and here also we have one scenario, and here also we have one scenario. Okay, so basically we will look for 2 small f and 2 small b, because blue is the recessive and white fur is also recessive character, right? So when we have 2 small f, then we will have white fur, and when we have 2 small b, then we will have blue eyes. Okay, so what is the then probability? So 1, 2, 3, 4. And do I see somewhere else? No, here one capital F. No, here one capital B. Okay, so yes, this is the probability. So what is the probability? The probability is that out of the, we have in 4 cases, this out of total 16 chances, so which is actually 1/4, that is actually 25%. Okay, so we also solved question number 2. Now moving to question number 3. Before that, I need to erase it again, and as always it takes more time. Yep, and yeah, it is time taking. Okay, no, I don't wanna, excuse me for the delay. Okay, yeah, I'm struggling to erase this thing. Yep, finally. Okay, so I'll just get back my pointer pen, and I will also change the color of this pen so that you can actually see the difference in color. I'm just gonna now make, let's say, this one. Okay, so question number 3 is that what is the probability that the baby cat will be homozygous dominant for at least one trait? Okay, for at least one trait. Homozygous dominant, that means to be homozygous dominant. So question number 3 is this. Okay, question number 3, to be homozygous dominant, so then either I should have small b or small f. I mean at least one. Okay, for at least one trait. So homozygous dominant, this is not sorry, this will be homozygous recessive. I should have capital B, and capital F. So let's see where I have that. Homozygous dominant, here I don't have that, here I don't have that, here I don't have that, here also, here also, here also, here also, here. Actually nowhere, because to be dominant I should have capital this and capital this, either 2F or 2B's together. But if you look at this, in none of the cases that is the that is there. So this probability is actually 0%. Okay, so the probability is 0%. And finally, another thing is heterozygous for both traits. Okay, question number 4. Heterozygous for both traits. So that means heterozygous for both traits, which means capital F, small f, and capital B, small b. How many I have? So I have here 1 and 2. Okay, 1, 2, and 3, 4. Okay, 4. I think I only have 4. Basically, it's the same actually. So 4, I have 4 out of 16 chances. Okay, so which means the probability is 1/4. Okay, so the probability is actually 1/4. That's 25%. Okay, and so finally I have to calculate genotype and phenotype ratio. Okay, so to calculate genotype and phenotype ratio, first I'm gonna get rid of this. I'll just erase this. Good. This. Okay. Eraser. Okay. Okay, so I'll also get rid of this. And now we're going to question number 5. Question number 5, what is the genotype ratio? Okay, question number 5 is here. Okay, genotype ratio. So first, what do we have? Capital F, small f, okay, and capital B, small b. These 2. And we have small f, capital B, small b is 2. We have capital F, small b, okay, is 2, and this is capital F, small f. Okay, this is small f, and the next is we have small f, small b, small b. Other than that, do I have anything? And okay, capital F, small f, capital F, small f. Yeah, in none of the cases capital F, capital B, small b, and small f, capital B, small b, small f, capital B, small b, small f, capital B. Okay, this and capital F, small f. Yeah, capital B, this small f. Okay, another will be small f, small f, and then small f, small b. This is already there. Okay, I don't need it actually, so I'll just erase it. Sorry. So erase this parts, and I will just write it down again. Okay, so the thing will be this. Okay, so this will be small f, small b, small b. So in how many cases I have this capital F, capital B, small b? 1, capital F, small f, capital B, small b, capital F, small f, capital B, small b, small capital, yeah, actually 4. This is 4, is 2, and small f, capital B, small b. Okay, small f, capital B, small b here, and small f, capital B, small b. So basically, if you count in the table, actually there is total 4, and for this one also there are total 4 cases. You just need to count in this, and for this one also there are 4 cases. So basically the ratio is 1:1:1:1. So this is the genotype ratio. So for this, okay, this is capital F, small f. So this will be black fur, okay, black fur, and capital B, small b. So then this will be black fur and another cat with white fur and brown eyes. Okay, this is black fur and brown eyes, and this will be small f, small f. So this will be white fur with brown eyes. Okay, and this will be also this is black fur, capital F, small f. This is black fur, and BB, this refers to blue eyes. Okay, and this will be actually okay, so this will be then now is white fur with blue eyes. Okay, so the phenotype ratio is also same as genotype ratio, because this genotype we have 4, and for this we have 4 and 4, 4. So 1:1:1. So genotype and phenotype ratio is the same. Okay, so I hope this video was helpful, and thank you very much for your kind attention. Please subscribe our channel for more contents like this. Thank you.